And now we'll move on to the questions. So we have our first question by Celine. Celine, would you like to ask it yourself, please?
Yes, sure. Sorry. Yes, I was wondering, in the numerical experiment, you see that at high load, it can happen that your policies underperform. And I was wondering, did you try to, instead of selecting DF fast servers and DS slow servers, simply choosing D servers, but with probabilities that are proportional to their service rate? And in this case, you would still sample fast servers more frequently than slow servers. And I don't know, maybe you would have more diversity in the assignments.
Yeah, that's a good question. Everyone can hear me?
Yes.
Clearly?
Yes.
That's a good question, and we worked out of that question on our. Let me get it right. So you're telling, like, instead of fixing DF and DS, like how we did in our paper over here, like let DF and DS be proportional to, let's say, a server speed or some other metric, like some other parameters, right?
That was not exactly that. It was always choose D server. Sometimes it might be possible that you should choose more than DF fast servers, for instance, but simply a given server will be sampled with the probability proportional to its service rate. So I'm not sure it's the same.
Yeah. So thanks. So we did address that, like, on our, so that was like an expansion of our work that we worked further with. So we did present a paper on MAMA, and that's what we did over there. Over there, what we did is we fixed on D, and then how many, and like how D is allocated across like the fast and the slow servers. Like we did different, like you said, like we called it like a balance routing. So that will be kind of proportional to like the speed of the server, like a probability of a particular server of a particular speed being selected would be proportional to like the speed of the server, and like the proportion of servers in the system that is of that speed. Not only balance routing, we also check with like many different much more general policies. Like in our paper, we called it like the independent query mix in the MAMA. If that would address the question that you said. So where we even put that, like the probability of queuing a particular server, we put that like a decision variable. So the optimization would actually find out like what would be the best probability to actually set to actually select a particular variable of a particular speed. Yeah. But yes, that we did not do that over here in this paper, where we just fixed DF and DS, and we kind of just mentioned that if you have D, you kind of enumerated all possible of DF and DS, and you can kind of find the maximum one. But what you mentioned right now is a better policy, and yes, that was like our further steps. It was after we submitted this paper. That was like further steps that we did to improve our policy. Thanks for input.
Okay, thank you.
Okay, thank you. So we have a question next by Isaac. Isaac, go ahead, please.
Sure. I was wondering, you were focusing on stability results in this talk. Are stability results like this one known for any of the other policies in that you mentioned, or other ones people might use in this area? Or is this the first thing with a nice stability result like this?
Let me. So you're asking like the way that we define stability and the way that we presented our stability. Are you asking if it is like the first time that we are doing it? Is that what you're asking?
Right. Is this the first policy known to have this sort of stability result? Yes.
So most of the policies that we kind of compared, that we had, to the best of our knowledge, we had only policies from like that was taken from homogeneous server systems, and then kind of what do you call applied on the heterogeneous server systems. And yes, like those, like the weighted JSQ and the JIQ and the JSQD, we found out that it need not be stable at when the load is high in heterogeneous systems. Need not be, depends on the problem parameter setting. So in that trend, in that, one of the contribution of the policies that we introduce is like they do give us stability at any loads. Does that answer your question?
Yep, thanks.
Thank you.
Okay, thank you. We have time for one more question if anyone has a question. That's online. No, well, I'll ask a quick question. In general, all of these sort of load balancing works. There are certain assumptions on the file size distribution, and does your analysis have similar assumptions, or can we get away with relaxing some of those assumptions?
Yeah. So the analysis that we did for the first policy that we introduced, the JIQ DFDS, we could work with any general service time distribution. However, the analysis that we presented in the paper for the JSQ DFDS is just limited to, like, we could do the analysis for just we only did for exponential service time, and it would be interesting to see like like the next step of like doing a JSQ DF, or similar to, we can't do exactly join the shortest queue, might be like remaining work or expected work length. Like on a JSQ setting, it would be kind of like next step in work that we do. But for the one that we present in the paper, it was just limited to the exponential service time for the second policy.
Did you, I didn't catch it in your presentation, did you try any simulations with other kinds of file size distributions?
We actually did, but we didn't present it in the paper, and it's more of like we are still working on how it would kind of perform in the general service time distribution. Yeah. But for the JIQ DFDS, the analysis is applicable to the general service time distribution, and for that we do have results. But yes, we did not present the results in the paper, but because it was quite in line of what we presented with exponential service time.
Okay, great. Well, thank you. Thanks to everyone, all the presenters and those who have